Here you are on mute.
Sorry. Let me just introduce myself again. So, hello and welcome. Hello and welcome. Yeah, hello and welcome. So, it's just kind of a technical glitch. So, hello and welcome. We are here for our second session in our event, Tech Day Pakistan Co-Pilot and AI. And in this session, we have Nandani and Joanal. Joanal, am I pronouncing your name
Yes.
correctly?
Yes.
So Jonal is with us, and my co-host Adnan as well with us over here as well. So yeah. So now it's so I will hand over to Nandini and Joanal, and then they will take it from here. Yep.
Sure.
So I'm sharing my screen as I'm sharing. Yep. So you can see.
Sure. Should we start? Thank you, Shakir,
Yep. Yep.
and for having us today. Today, what I think I and Nandini will be talking around is how do you do RAG on Azure using the services, as well as we'll dive deep later into fine tuning these models and how you can enhance your systems. So just let me know if my screen is on visible. I am audible, right, so that we can start. Uh,
Yes. Yes.
Perfect. So I think to start with, right, we all know these limitations of LLMs, right? The LLMs tend to be out of date on the like the cutoff date of the data that it was released. Right? I think initial versions of the GPT models which went viral were having data up till 2022. Then every time there is a release of a new version of the model has a cutoff date on public knowledge, right? And second is also these models necessarily don't know your internal data, right? Unless you have used your internal data to tune or uh, train the model. Otherwise, these models don't know your internal data. Right? For example, if you ask a question like, "Do my company funds cover underwater activities?" Right, the model might not know, right, because it had not seen that data. And in this case, is for us to give now additional information to the model, right? to give that contextual information to the model so that the model can comprehend that, process the data, and then come up with the answers to the question that you ask for, which is where we start using RAG, right? So, incorporating that domain knowledge, there are multiple ways, right? One is prompt engineering, is essentially we put all of these necessary data into the prompt itself, right? But that will make your prompt very large, right? You cannot necessarily give the whole book or the whole internet in the prompt to for the model to now go through that and give you an answer, right? Second is the other way of doing this is fine tuning the model. Essentially, you train that model, fine tune that model in a subset of your own data set so that the model now understands your domain, the model understands maybe the company related information or any specific thing you want the model to learn, and then it can then answer basis that, right? And the third and a widely popular way of doing this is using retrieval augmentation. So essentially, what we are doing is we are not training the model. We are using traditional search, right, to find, okay, if the user is asking that question, where I could find that answer, get the data, now feed that model using prompt engineering so that model can have a look at it, comprehend that information, and give us those answers, right? Uh, for example, this, right? If you look at the solution, right? If the user comes and say what is the best shoe for hiking, right? What we are doing is we're first essentially doing a search to understand, or doing a retrieval part, right? Okay, which hiking related shoe data that I have in my database. We get all of this information out, and here you can use various kind of ways to search that relevant document, right? We will talk about various ways of doing that a bit later. But yeah, once you have these related documents fetched out, you basically send that to the model saying, hey, this is the question my user is asking, this is the data that I currently have, can you frame an answer for this, right? Now the model goes through the question, the instruction that we have given to the model, the additional data that we have passed to the model, and uses all of this information to now give you an answer saying, hey, for great hiking shoes, consider Trek Extreme, right? Because you see here, this was the uh, product which was fetched from the database. And essentially, this whole process is called retrieval augmented generation, right? So retrieval is when you search for a related document for that query, which is the retrieval or search part comes in, and then you use that data to augment the model's knowledge, and then finally go ahead with the generation of an answer. Right? What is RAG searching, right? So now, using RAG, you can essentially search structured data, maybe things like databases, or you could also look or search across unstructured data, right? It could be PDF documents, doc files, PPTs, HTML, images, and whatnot, right? It's just that the ingestion pipeline differs a bit. You have to kind of extract the information out of those documents and ingest them in a vector, some kind of a searchable manner, right? So that when a user query comes in, it's easier for you to now search those documents and then get those out for your model to now comprehend and give you answers, right? Uh, High level components of any RAG solutions are essentially retrieval augmented generation. We just need, or high levelly, we just need three things, right? One is a powerful search, right? Whenever I talk to anyone about RAG, I emphasize always on, it is primarily a search problem, right? If you can solve your search really well, rest of the things will be in line, right? And then that search involves, what kind of search you are doing, right? Are you just using vectors to do search and find relevant documents? Are you using more sophisticated manners like semantic re-ranking, hybrid search, and some of these things, right? So we can talk about these later. Second is, okay, now you have a search built, right? How do you, and the second is, in that search to work well, you need a very reasonably sized data, which is pre-processed well, which is indexed in a manner that it is easy for you to find those contextual information later, right? And then third piece of this puzzle is your LLM, right? So ideally, we can go ahead and take an off-the-shelf model like Azure OpenAI and any of the models that we have, or any model from our math surveys, and use that as a part of these pipeline, right? But if you are building something very niche, right, might be the terminologies that you are using might not what the model might understand, which is where you would need, or it is advisable that you go ahead, fine tune that model so that the model understands your world, and then on top of that, you can do that so that it understands what you are asking, it understands what kind of answer it has to give you, and then adapts itself for that. right? Firstly, when I talked about search is vector embeddings, right? So essentially, what we do here is convert all of these documents, right? Every character, every word in those documents into essentially a list of vectors, a list of numbers, which represents these text in a very like in a vector space or a latent space, right? And then we can use these numbers to kind of now compare uh, how these models or how these two pieces of text are similar, right? One and then which is where you the reason why you need a lot of these, let's say, OpenAI text embedding ADA small or other sophisticated word encoders and not are yes, you can use traditional encoding techniques like when you one hot encoding and others, but the reason why you need something very sophisticated is I think it'll be good to share this example, right? Consider two you have two sentences, right? Your work is to play not teach, and the second is your work is to teach not play, right? Now when you do a one hot encoding, right, the vector that you'll get out of both these sentences exactly would be the same, because you're just looking at, okay, if the sentence has that word or not, right? It's the same words across these two sentences, but the position of these words in that sentence is what's actually changing the meaning of the whole sentence, right? Which is where you need like positional encoders to understand, okay, how the context of the how the meaning of that word, meaning of the sentence changes when it is used with other words, right? And which is where these models help you to build that context, pass that understanding to the LLM, saying, okay, this is what these random combination of words mean, right? Then once you have these vectors, right, what we use something called as a cosine similarity, which is the simplest form for us to compare two vectors. Essentially, what we're looking at is what is the cosine, uh, you know, like what is the degree between these two vectors, right? For example, if you see there's a v1 and v2, and we're just looking at, okay, how much separate these are. If two vectors are exactly same, this degree would be zero, which means the value would be one. Otherwise, if they are totally opposite, the degree would be and the similarity would be zero, right? And then if you see here, what you'll see is similar looking words are always kind of structured together. Right? When you convert all of these words into vector and then plot it in the graph, you'll see similar word which are of similar meanings are clustered together, right? So that it is easier for us to now find the similar words and then text in which are similar, which talks about the same thing, and then get that information out to now pass it to the models to answer. Right? Yeah, so essentially this is what we are doing in our search, right? So you get a query, you get a question saying, what, maybe let's say, when is Tech Day Pakistan happening, right? Now that data is stored in some vector DB. First to do is you convert that this question, right? When is Tech Day Pakistan happening, into a vector, and then you now search that vector in your database, right? Okay, for this question, so Tech Day Pakistan happening, right? And now you get closest vectors, right? Documents which might be talking about, maybe some document will say the earlier that this event was going to happen, right? And then maybe there could be an email which you might have sent saying, hey, Tech Day Pakistan has been rescheduled 28th, right? So you will fetch all of this information, multiple documents which talks about the date of the event, and it'll work something like this, right? So you use an embedding model to convert that to vector, then find the related text for that vector in the vector database, right? And Azure AI search is able to is there to help you to that, right? Essentially, if you can even have use or like use this to convert any kind of information into a vector into vectors and store them. It is seamlessly integrated with semantic kernel, LangChain, LlamaIndex, and other services for you to just build those LLM driven solutions at a very large scale, right? Yeah, there are, I think, I might skip this more around how exactly this search works. uh, but yeah, so using AI search, essentially what you can do is, it's not only the text you can search, right? You put in just images, sounds, graphs, and all kind of other data, other multi-model data, ingest them, and then again use this search for relevant information across these different modalities and get this information out for you to now ingest these two models to generate answers, right? Uh, then the next piece comes is once you have this information out, you're sending it to the model, right? Here is a very reference architecture for all of us to kind of have a look at it. So we started here, right? Let's say you have your data in some storage account, right? What you do is you use a function app which now reads the file, processes this data, chunks them, basically brings, because a large document cannot be ingested at once, so it breaks them into smaller parts and then embeds them. At maybe if there are documents which are very elaborative, which might have images, tables, and other things, you might want to use Azure AI Documents intelligence to kind of extract the data. And then once the data is extracted and converted to vectors, you kind of usually store them in Azure AI Search, right? Now, once the data is there, whenever a user query comes in, essentially you are using the same embedding model to convert the user's question into an embedding, getting those relevant documents out, and then sending back to the Azure OpenAI service to reason over those chunk documents, right? And then give you in context answers on the questions that you have asked so far, right? Any questions or like are you taking any questions, Sudhir, or not? Okay. Yeah. If yeah, sure. Yeah, and then essentially okay, moving ahead, right? So you see a lot of these assistant use cases that are coming up. We have kind of have copilots for every piece of work that we do today. So this is a reference. Sure, sure.
If I just may ask,
Go for it.
is
Go for it.
it like kind of these rag the whole model and everything is kind of the baseline of the Copilot we use in M365 and Power Platform? Is it been used
Yeah.
underneath?
So this is a very typical architecture, right? So any RAG solution that you would see, right, that talks
Yep.
any chat with your data use case, right?
Yep.
Be it inside M365 or other solutions, it
Yep.
uses the core idea is this, right?
Mm.
Now the product level changes, maybe for us to build that M365 logic, there might have been some changes, right? Maybe there might be changes on how the data is ingested, how it is stored. There are security, there are other challenges
Mm.
in there, right? And at the same time, you would also want to do some sort of role-based access control.
Yep.
You know, right? So the
Mm.
architecture changes according to that. How the architecture will play out in a larger product sense. But at the core, this is the whole idea, right? You essentially build
Yep. Yep.
this. So this becomes your foundation, and on top of
Yep.
this, you do your customization to fit your solution on what kind of application that you want to build.
Yep. 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 All right. Yeah, that's good. That's really good. Yeah. So you can carry on. Yep.
Sure, thank you. Yeah, right. So in a larger sense, right? So now it's not only that you have to use AI search. Right? Essentially, this whole data ingestion pipeline can be integrated with, let's say, as an Fabric signups, like data engineering pipeline, right? So which takes the data, processes them. There would be notebooks to process, enrich, vectorize this data, and then finally index them. And then you could use things like prompt flow to now build that like use case. You could use even there are other things, right? Things like function calling. There are things like assistance API. You could use a lot of those things to now improve that solution, right? And then finally gets exposed as a front end application, maybe as a Teams agent, chat agent, and whatnot, right? For the end users to now have a look at, have access to that, ask different kind of questions which are now grounded into the data that was supplied to the model. Yeah, while we talk about these solutions, right? A lot of times, like I said, right, the foundation is same, right? But there are tricks in that we can use to kind of improve the solution, right? In this, maybe in the next 5 minutes, I will give you some tips and tricks that you can use to kind of improve the overall performance of the solution, get more out of this, right? There are things like, I think, starting with use token compression, right? Don't don't always ask, let's say, model something very large, right? Prompt an LLM to return shortest possible response, right? You don't, if an answer can be of 10 characters, why do you want the model to give, like, write an essay for it, right? A few simple phrases for you that you can use to kind of guardrail that, right? Put those checks and balances in place. I know you can do some future prompting for now the model to ground itself there, and then give you a very contextual, very minimal answer, right? And if you see, there are some notebooks available to this, but if in this example, if you see, you could get up to 2 to 3x more performance, right? The latency, the end-to-end latency got down from 20 seconds to 8 seconds, right? Second, in the same line, avoid using an LLM to output large documents. Right? If you know, okay, this I essentially want a document out, right, and that document might be ingested somewhere. You could just link it back, right? Saying, okay, if my search results gives me ID 1, I'm going to return this document, right? And that would not necessarily need you to ask the model to rewrite the same document that already exists, right? And save cost and latency there. Implement semantic caching whenever possible, right? So any of this application you'd see, we traditionally used to have FAQs, right? Frequently asked questions, right? So implement something of the same sort whenever you're building this copilot. Right? Look at, okay, if there are repeat queries that are coming up, right? Users are talking about similar things a lot times, right? Why do you want to generate the same answer every time, right? Versus you have a semantic cache. What it does is, whenever a question comes, you check, okay, have I seen this question earlier, right? And do I have an answer available to that? If yes, just fetch it from that semantic cache and give it to the user, right? So you just doing this, you could save like 14x your latency, right, down from 19 second to just 1.3 second for you to just do that search and get the response out and give it to the user, right? Use smaller models whenever possible, right? I think I am kind of a huge advocate for us to not use. Yeah. No. Yeah, so yes, the vanilla implementation of this will not actually give you a rephrased answer out, right? It will be just basis on what, let's say, if the answer came to you, maybe let's say when the Tech Day Pakistan is happening, right? It says, okay, Tech Day Pakistan is happening on 28th July, right? So it is the same answer is going to be for all of us, right? Versus what you can do is, in this whole scenario, right? To improve this, now you can add an SLM to the mix, right? Maybe I'll see if I can find a document for that, or maybe I'll just post that link in the channel, or share with you for you to. Yeah, yeah, yeah. So there is a document that, yeah, there's a Microsoft blog that I had wrote recently just for this. So I'll share you link for that. You can go ahead and read that. It's actually what you're doing is you're using an LLM or a large language model to generate that answer once. And once it is done, every time a similar query comes in, you are actually calling an SLM or a small language model to rewrite that answer, right? So that the answer looks in context, personalized to the user, but you are not spending a lot of time and your cost to use an LLM to do that, right? So from here, if you see, it got down from 19 second to 13 second. Improve, adding that might increase this just to like couple of more seconds, right? But it still be a good, huge improvement from calling that LLM always. Uh, Going ahead, it is always advisable for you to use a smaller model if that can do your task, right? That is suffice for the task, and not go uh, a model which is very big, because larger model needs more compute, they are costly, it takes more time to generate those answers, right? So latencies can improve up to 4x from 17 seconds to 5 seconds, right? And the last and the most important is in any software application, it is always have a load balancing in place, right? You don't want to overload your one API endpoint for hundred or thousands of users calling the same API, right? Versus you can use something like an APIM solution there to load balance, or you could use PDUs and all of these things to now load balance and make sure the users are getting the same experience, right? With GPT-4 Omni, what we have something called is a global deployment, right? What happens is earlier, if you have maybe let's say deployed a model is deployed in Singapore, right? Anyone in the world will have to come. Their request has to come to Singapore to generate the answer, right? Versus now with global deployment, what actually internally what the solution does is it will look at a nearest data center where that model is available and then get you information from there, right? Versus going across the globe to use that same model to generate the answer, right? And now these solutions can even improve the overall latency of the use case, right? A simple case study here, right? Let's say you are doing a document processing, you want the model to look at the document and correct spelling, let's say grammars and these things. The base application, with just vanilla RAG takes about 315 seconds, right? But at the same time, if you use a lot of these tricks which I just shared earlier, right? The latency comes down from just doing avoiding rewriting. It comes down to 38 seconds. Adding token compression and parallelization, you get 105x improvement, right? And the latency is now just 3 seconds instead of 315 seconds. At the same time, if you see other use cases, a RAG use case, the latency came down from 17 seconds using semantic caching to just 1 second. Right? So, these are some of the tips or the tricks that you could implement in when you are designing and RAG solution for you to improve the performance, incur less cost, as well as give that consistent good performance or good experience to all the users. Right. I think I'm almost done. So and I'd let Nandini take from here and then talk about like continuing this models. No, no.
No, I'll share mine, but you folks have to tell me whether you are able to see the screen. Great. Okay. I will need to put it on screen and let me know. Is it coming in as full screen? Okay. I see it. Yeah, because I see it as not full screen. That's why I'm asking. Okay. One. Now, is it in the slideshow? I tried it. Okay. Is better? Is better like this? Okay. Tell me if I'm able to go ahead. Okay. Great. Okay. I'll just continue in this manner then. For some reason, I'm not able to do a slideshow. Okay. Okay, I'll get started then. Hello, everyone. My name is Nandini Muralidharan. I'm a product manager in Azure AI space, and specifically looking at Azure AI Studio and fine tuning. As Joyner pointed out very clearly, RAG has its own very standardized benefits, right? It is helping us to get in any new information, new facts, baking it into the model. But it also comes with its own pitfalls. There is only so much context you can give. There is only so much of new information at a given point you can give, because if you give it more, your in context length will increase, because of which the system can become slower, token size increases, it can become make it much more expensive. So it will have its own. pitfalls, we go for it. And then what do you do at that stage? Okay, you have tried out prompt engineering, just as joiner you tried out prompt engineering, then we tried out RAG, and then it just still feels like the model is not my own. It still has something which doesn't make it feel like it is working for my organization or for my use case. What do we do then? That's when fine tuning comes in. So, what is fine tuning? Fine tuning is you take a great LLM, you train it with your own specific data for a specific skill or a task, and then you get a fine-tuned LLM. You get a model which works for you or which listens to you. Like a different parlance example would be somebody has studied doctor and wants to do brain surgery now. So you take a good doctor, you train him only on brain surgery aspects. You do not train from scratch. You train only on surgery, make it so good that you become the best brain surgeon. That's what it is. One task at a time, one skill at a time. Correct. One skill at a time. You're right. So that's what is the primary difference between why would you explore fine tuning, and that's why and that's exactly what this diagram represents. To saying you're training the model, you're training a few layers of the model for a given specific task, what you would want to do. Um, for us to go deeper into what this means, is there is a beautiful article here and a blog which is published in Microsoft Azure component, and then there are YouTube videos for it as well, specifically published by Microsoft AI. It talks about how do I customize an LLM? When should I choose what technique? And to fine tune or not is a very a deep question which folks ask, saying, when should I know that it is ready for fine tuning case? There are a few more examples given. Today, I will share a couple of use cases, the most common use cases of fine tuning. One is reducing of cost by shortening of prompts and teaching model new skills. So these are the two use cases we will go after in the meeting, in the discussion today. The first one, I want to reduce fine tuning. I want to use fine tuning for reducing the token size. So, say the left hand side, you see an example. I am giving it a sentiment, then I'm giving it a question, then I'm giving it a few examples, and then asking for a response saying, tell me, this is like a classification problem, right? I want to classify this. Tell me if it is positive, negative, but I'm giving you a few examples. I'm giving you the context of what is happening in this space. And what is this called in normal parlance is few shot prompting, right? This is exactly few shot prompting. That's what we have done. And we have gotten out. Now, if you do a fine tuned model, you don't need to give all this context. Neither do you need to give examples. So, what would it be? You give a prompt, I'm stuck on the motorway, and just the answer comes in. The input size of the tokens and the output size we see clearly in this example has reduced. So you're just getting too good in doing just one single task, and that's exactly what this kind of demonstration is. It will make it cheaper, it will make it the latency or the performance would be better purely because of context length itself. So you have trained the model to do one task well, like a classification task, and it's able to learn that skill and do it very effectively for you, both on the input token side and the output token side. Okay. Let me go through one more use case and I'll then just stop in for a few questions and then we'll go deeper. So, this is one more type of use case wherein the model knows how to write, how to play chess. Okay. I would want to format the response or the output of the response, change the way the model is reasoning things or learn the way how model reasons things and then alter a few bits. Similar to example of the brain surgeon. He already knows MBBS, right? Or the equivalent doctorate degree in you already know a basic doctorate degree. So you would not forget what is the ICU protocol just because you're doing brain surgeon, right? Or you would always know tetanus is given. So that part is not altered. What is getting altered is the delta which you would want to teach the model, which is exactly the chess example. So here, if you see FSL stands for few shot learning. In few shot learning, if I just do a best of all K shot, which is a few shot prompting piece on GPT-4 and GPT 3.5, look at the way the accuracy is. But if I'm able to teach that same skill specifically on a supervised fine tuning model, then I'm able to jump the accuracy almost double. Going back to the first thing which I started with, your model becomes your own. You're able to customize a model to make it listen to you. More, it sounds like Harry Potter movie, but it's not. It's like wanting to do some specific skill sets really, really well without underlying the fact that, and which is the most important part which I want to share, is without altering what the model already knows. Why? Because the model knows quite a bit of things with what it has learned. You do not want to change anything what the model is very good at doing. And that's why a fundamental thing in fine tuning would always be the way you test the model. You would want to test it in scenarios which it is good at and scenarios which it isn't bad at. Bad is what you're trying to improve. You are not trying to degrade the good. And that is why there is a lot of skill associated in training a new skill on the fine tuning part. This is exactly what we do with your evals data set or your training. So when you have a training and validation data set, and I will go through one demo now for Llama model, but that's what you do. What we would do is you would keep your test cases such that you would want to test for both before you sign off on the model, or you would want to train it. So you typically, and this is classic ML, it has always been, nothing has changed here in the last 1 year. You always test it with multiple use cases on a smaller model across the segments which you would want to test into. It can be accuracy for some, and it can be conciseness of response for some. But take examples such that it is bad and good both. You do not want to alter good for your, because these LLMs are extremely powerful. I might not say the same thing for maybe a model which was built before the LLM era. But for LLM, you are going for it because it is very, very good in some cases. And you would want to enhance that capability, just like how you enhance a child's capability of doing something which they are good, you do not want to alter. It's the same principle we use for fine tuning as well. Okay. Any questions, Shakir? Sure, sure. Now, let me go on to the models available, and the latest will always be on the Azure AI website. We also have launched Llama 3 recently, that is about 3 4 days back. But there are multiple models available for fine tuning. That's all what I want to share in this site, in this slide. Saying there are multiple models. If you click on oai.azure.com or ai.azure.com, you would have multiple models with fine tuning capabilities. And why I'm specifying in it, a lot of times models get released, they might not have fine tuning capabilities. Then it might not be something which you can utilize. Now that you would know, okay, there are plethora of models, I can choose some of them, and these are the models I want to look at. There are a lot of questions which come across our way saying, what type of fine tuning techniques do you use underlying? What we do, and that's exactly why, because there is so much of science and skill associated with fine tuning the model, right? We are trying to productize it in the models, and that's exactly why LoRa models or low rank optimization approximations methods are the ones which we propagate. And there are few models we have quantized LoRa as a mechanism as well. But from parameter efficient fine tuning techniques, so that you get best results, performance, latency, accuracy at a considerable cost, etc. LoRa techniques are the ones which OpenAI thrives on. We also do the same. And then that's why, by default, for all the models, LoRa is available. So when you do a fine tuning, you do a LoRa fine tuning technique, which is by default enabled. You don't have to do anything to choose it. Now, is all hunky dory in fine tuning as well? Like what Joynal spoke about in RAG, is all very good in fine tuning? No, it has its own challenges. What are the challenges? What are the challenges of fine tuning? The first one is data. I'm very clueless sometimes saying how much data is enough for me to fine tune the model. Do I need a very large data set or it is like a small data set? What we have seen from our experiments, Shakir and team, is it has been that even if you get some thousand good tokens, it's great for you to fine tune a model. Okay, it so fine tuning should not be looked at as a restriction to say that, oh, only if I am a big company, only if I have large data sets, then only can I do fine tuning, or otherwise I should not even. Not true, not true at all. However, you need diverse data sets. You do not want the same examples thousand times. The model doesn't need that. You would need correct, correct, or complexity of the cases itself. Correct. Or different parts of the brain, like medulla oblongata will be a different thing, cerebral will be different, things like that. So again, focused on the skill which you would want to train. If you would want to train on a very specified skill, there will be three, four variants. Ensure your data set is similar to that. One more nugget we should remember is don't overtrain it on something which is the rarest of the scenario. You would want it to become like, for example, if Tech Day Pakistan is happening and you have a population of so many people with so many backgrounds coming in, you would want to cater your input examples also to the same kind of samples. You would not want to cater it to a very differentiated set. So if I'm getting X amount of case for cerebral malaria, I'm just giving an example, and only the rarest of the cases for this, I would want to train 80% of my training samples in cerebral cases only, or malaria cases only. So depending on how your output will get utilized, try to mimic your input or the proportion of the input data. So fundamentally, you don't need large data size. You need varied data size. You need high quality data size. And then the science behind it of proportioning, use the same as what you get in the output. The next one is challenges, computational horsepower. It's not easy to train LLMs, right? It requires a lot of storage, it requires a lot amount of compute. How would I know how much storage do I need? How much compute do I need? How much do I need fixed? How much do I need variable? It's a challenge. I do not know that today. Right? And that's exactly why the product is trying to bridge that gap. The third one is the expertise needed. Like I spoke about parameter efficient fine tuning techniques. There are multiple techniques available. What kind of hyperparameters should I choose? What kind of data samples should I do input versus output? All of these are expertise skills which are needed. Hence, the barrier to fine tuning increases because maybe in an organization which has very skilled resources, it's very easy for us to do these examples again and again and again. For organizations which might not have this kind of expertise in house, then it can become like a barrier to enter itself and to recognize the value for it. Any question? I'm hoping this resonates. These challenges. Sure. Great. So then, what do we do? Does it mean that fine tuning is a daunting task which is not to be done? No, that's exactly why the product is built out in a way that we are able to ease out all of this for the people for 80-90% of the scenarios. So that for your majority of the scenarios, for you to experiment, for you to validate, for you to train out a couple of skills, those barriers is what is getting broken each day. So we spoke about this at a high level. Hmm. 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 No, and I'll take you through the example, one live fine tuning case, or not live, a recorded demo for simplicity, but I'll take you through the recorded demo. The data primarily helps us in, again, as I said, be very focused on what goal it is. If the goal is teaching model classification, if the goal is cerebral malaria understanding, right? Whatever your skill is, once we have to decide the data on the parameters which we discussed out, saying that variation has to be this much, size is not a barrier, etc., etc., align it, like format it in a manner that the model recognizes it, and then utilize cuts of it so that you can make it repeatable, because you would want to use a similar data set and then try it out multiple times, right? And that's exactly what the data bridging does. So if we are able to very very clearly, and there are many sample format files, like for example chat completion formats, there are many sample files for people to start playing around with it. On the website itself, on Azure, you would find a lot of document in terms of how do we get started with simple examples, saying adding two numbers, subtracting two numbers, things like that. Like get a handle of it from things which you know very very well, and then and that will also help us to understand, be focused on very our skills on what we would want to that model to train. It's very similar to teaching a child how to work on one thing with us, and that's why repeatability of examples, proportion of examples, quality of examples, everything help, because otherwise it will be garbage in garbage out, and we will not be able to control. And it's true for all humans, right? Like, repeat it in the same context, how much you will use it. And that's what we should remember. Don't repeat an extreme so much because you might not use it 9 out of 10 times. Absolutely, absolutely. That's the crux. What you called out is the crux. Understand how your audience or users of the system will use it and mimic that in your input. And that's the skill. But if you do that, um, you will be in a far better position than when where we begin with equal samples of all examples. Then it just becomes like probabilistic scenario. You don't need an LLM for it. I'll just show one demo very quickly, if that is okay. This is my last. If folks would be interested, I can show this. Otherwise, I'm good to take questions. I'm just starting this off, and as it comes, I'll talk to this. This is our URL ai.azure.com. Today, I'm taking an example of a Llama 2 model. As I said, there is GPT 4.0 and Llama 3, and all the greatest have been launched since then. But this is one which we showcased in Build in May. But the focus of this demo is purely to understand the process of doing it, so that irrespective of the model, you can pick the same thing. So here, for an example, we have taken Llama 2 7B model. What did I do? I did OAI or ai.azure.com. I picked up a project, and within the project, I picked up the model. Uh, the model, we go through it, and when you select the model, all the pricing terms and agreements are written out on your card. Depending on the geography you're in, it might get customized to that geography's rates. But this is what is coming up from a US subscription. So this is what I have used for a US subscription. Why I'm calling this out is, remember, one of the challenges was computational horsepower. If you would want to go to a model like this, you do not need to worry for it, because you will use it and then you will pay as you go. Which is the model which is the pricing which I wanted to highlight. That's the only intention for highlighting this slider, because as I said, models and pricing will keep changing, and you will get it in the model card. So let's start with fine tuning. What would we do? We pick out the model. Llama 2 was my base model. I called a name for it. Here we've reached as a build for. And then I add in my training data into the model. Now, this training data, I can upload the file in the chat completion format. I can also view that file to see that, okay, whatever I have uploaded, is it uploaded correctly or no, through the same screen. So what you would see here, this is a file which I've uploaded about vampire bats and what type of bats they are. So I know the input data column and the output data column, and then I map it. So what I do it is required data columns. If you see down, there is a column A which is text and column B which is ground truth. What I'm mapping this is the input, which is the prompt column, and the output, which is the completion column, right? That is what I'm mapping, saying Excel, this name stands for prompt, this name stands for completion. And I enter the next button. Now the next one is validation data. What does validation data do? Some part of training data, I will not expose it to the model upfront. Similarly, the standard, I would keep 15% of it for validating. So now I have two methods. I can do that splitting initially itself and keep it in two files, which is what I've done in this example. Or you have an automatic splitting as well option. So you don't need to enter a separate validation file. Azure will do that for you behind the scenes. It will split some training samples and keep it for yourself. So even that is possible. In this case, because we have done that splitting upfront, I'm uploading it here. Once we do this, we come to task parameters. And this is where I wanted to spend some time. And we'll just use an analogy of the same person who's studying to become something, right? Batch size multiplier. Batch size multipliers means number of training samples being passed through the model before the model's internal parameters get updated. That's what is the definition. What does it mean? Suppose I read a book, and what we will do as we read book, after every 3 pages, we shall start taking notes, right? 3, 4 pages, we'll take notes. 3, 4 pages, we'll take notes. Why do we do that? So that we remember whatever we have studied for the three things, so that it's just memory, and then we go to the next one. That is exactly what you should imagine as batch size multiplier. For after so many training samples, it will go and update the model's internal weights. If you have a very high batch size multiplier, what will happen? I read 100 pages and then I might just forget what is needed. Uh, and my model parameters might be updated very non so frequently, right? So I might miss out on the details. The other part is if I do it after every one paragraph, what will I do? I am overtraining the model. It might just see that I might never finish my book itself. That is what is batch size multiplier. An optimal number is critical. What we have done from Azure side is we have abstracted it. We have just made it 1, 2, 4. There are only three options which you can select. One typically comes in as your default parameter. Even if you use the OpenAI models here, you will get one dot saying default, default, default. If you just go for default, default is based on our experience. What 90% of the scenarios happen, that is what is kept as default. Which is the batch size multiplier. We have seen in most of the cases one gives good results, so we've just assumed that to be here. The second one is learning rate. Learning rate is the speed at which you learn, right? That's what the name suggests, the speed at which I learn. An average person, say, reads about 300-page book in 3 hours. Okay. So if they read it so quickly, it's fine. But if somebody is, say, trying to do that in 1 hour, then you feel that okay, if I'm doing it faster than average, maybe I'm not learning enough, right? That might be a drawback. Or if I become a very tough parent and I say, no, 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 understand every word of what you know. So please open the dictionary and understand that word. Understand that word. You will spend so much time in learning that you will end up or kill the joy of reading, right? And that's why, correct, correct, correct. That's what is learning rate. You do it faster, you will finish your training faster, but you might have skipped many of the content which you really want to go at deep into. So like the skill which you wanted to learn, you might have totally skipped that skill and went to the next one. But if you go too slow, you will take so long to just come to that skill that the other skills will get missed or other examples will get mixed, right? That's what is learning rate. So here with some examples, we have picked up a learning rate of 0.002. So that is the learning rate. That is the fundamental understanding of learning rate. Now the last one is epoch. Epoch is the number of times the model is trained in entirety. That is, same book example we take. Sometimes I read a book and then I feel I not understood this correctly. सही से पूरा समझ में नहीं आया. Like if I've not that everything I understood correctly. So what will I do? I will reread it. But how many times will we do that? How many books we do that? Very few, right? Because the amount of complex books are very less. That's exactly what is epoch. Epoch is the number of times you will run the training samples on the model again. And here for that example, we took one because it's one was enough. It was not such a complex example. Okay. Now we have hit the deploy button. So you start saying, okay, train the model, and the model will get trained as you with these parameters. Depending on the size of the data, uh, depending on the region which you have chosen, etc. it will take some time for it to be getting trained. Once it gets trained, and I'm just going through an example where I already trained model, I'll deploy it. I'll deploy it in a cluster and say, this is my name of the model. Why do I deploy it? Because this is the model which I created, right? This is the model which is for our use case. This is not the regular Llama 2 model, base model. We have made it for our use case. It understands my language and my task. So we name that model, we deploy it. Now that we have deployed it, are we good? No. The most important thing what we do is we start testing the model. We test the model because the model with its validation data has already done some testing. That's why it has given us some metrics, right? But what we do now is the last part of testing which we spoke about, saying what you think the users will use, go and ask the same questions and check whether it is giving you the answers which you would want. So let me take you through the prompt flow here. Okay, I'll give you an example. This is a base model. So first, I'm giving you an example of base model, that is non-fine-tuned model, Llama 2. I gave it the input format. The format, the graph is very similar, right? I have an input string, which is the question string, and then there is a completion string, where I will ask it to give me a response. Um, and this is the graph, prompt graph, which we have created. This is this classic prompt engineering, which you would do. So now in this particular case, when we added out the graph and given out a question and the content, this is the value which, if you see on the right side, this is the value which I've given. This is my content. So my question is, you give. I'm giving you the context, saying read this paragraph, find out what the answer is, tell me the answer in this format. All the context I'm giving, and then I'll give you a few examples, like I spoke about in the few shot learning. I'll give a few examples because that's when we know prompt performs really well. So we give a few examples and then ask it for a response. Saying, give me a response, and your response must begin with this question because, as I said, this is also the format of the response. So you give all of that. Okay. The moment it starts with all of it, then it will go ahead. It will uh, it will pick the right amount. Sorry, and then I just say hit or run the entire thing. Okay. Once I run it, I just waited for a couple of time. This is what I'm doing in the dev instance. So, and I'm looking for a response now, saying, okay, given that I have given a paragraph, what is the answer which you are giving me, model, as part of the base model completion? Okay. Um, uh, let's wait on for a couple of seconds more, and it will just come in. Yeah. So this is where I have the response. See, the question I have asked: what kind of vision do most microbats have? Then it says there's limited visual acuity and this they rely on ecopolation for navigation. And then it gives me an answer. This is my explanation. This is where I have picked up the answer from, etc., etc. Now, because I know the data text, I know this is not the most accurate answer. Okay, and it is giving, but it's formatting in the response because I've given a good any context. Okay, yeah. So now you see context length input and output was heavy, right? Because it has to do it. Now let's go on the fine-tuned model. So now this is the base model flow. Now I'm going to the fine-tuned model flow, right? Fine-tuned model, the graph is very similar. Just that I am pointing it to the fine-tuned model now. I am not pointing it to the base model. That is one difference. Second, if you see the context length itself, which I give now, I've chosen a few parameters, but I'm giving a few context length. See this one. My context is just context question, 2 lines. That's it, or 2 words. No such big paragraph saying this is the history, this is the geography, do this, do that. Nothing. And I'm giving the same example, and I'm asking it, okay, model, now tell me what the answer is, and I'm running them. What does it say? What kind of vision do most micropaths have? Can you see a very concise response? It says mesopic vision. No theory, nothing. It is giving me an explanation in the format which I want because I asked for, saying, when you get an answer, tell me from where are you getting the answer. And that's what it's highlighting here. And it's giving me a very concise response. That's one more of a specific skill for fine tuning, that it gives you a very concise response. So it reduces input output token length. It can teach a new skill, and it can give you a very concise response or format the response really well. With this, I'll end. So if you think any questions, please go ahead.
put my into the screen as well. Yes, so they may be like coming into like trying to learn it. So, what would be the best pathway or the Microsoft? Is there anything on the Microsoft Learn, so they can go through it and then they can reach to this level? That's okay. Yeah, I'm here to rag, and then now I'm touching this fine tuning as well. So, if you can recommend something.
No, absolutely. So there is tons of document. Like as I said, ai.azure.com is your place, or
Yep.
oi.azure.com is your place. There is tons of documentation, including tutorials, in terms of why to choose which customization technique.
Yep.
Okay. And then if you have come down to fine tuning, then there are tutorials on how do you do fine tuning effectively. And as I said, the product is focused on abstracting it so much for you so that you come with a good use case. Be very clear on your use case.
Yep.
Saying I need to teach new skill, and this is my skill, and this is the kind of data which I have, and then the remaining part is getting sorted very very easily. Like it was not like this. I would not say it was like this 2 years back.
And
Uh,
does it break the bank as well? Bank account? Does it ask for like the as the money itself?
So
like
that's exactly why the PG model is very, very good, Shakir. So
very
if
very good.
you
Yeah.
want to do dipstick experimentations and then and say experiment for 3 hours and then kill it, Paygo is a very good model than you making a commitment for a longer time, saying I
Yep.
need for a month or 2 months or 3 months because we do not know, right, whether this will work for
Yeah.
us, not.
Exactly. 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 Yeah.
So if
That's
it is
right.
like a startup kind of ecosystem or a not a globally recognizable path, right? Then it's
Yes.
absolutely good for us to use the Pego model, go
Yes.
test,
Test and then yeah.
see how it has been working out for 10, 15 days, play around
Yes,
with
and
it,
then yes, yes,
build your process,
and then kill
and
it.
then
Yeah. That's right.
Azure credits as well to get started. So it should be
Yep.
good
Yep. All right.
depending on the regional setup.
Yeah. All right. Thanks, Nandini. Thanks a lot. I think Joanna already left. So, but thanks a lot. Thanks for your time. It's such a lovely topic and such a like so much information that still I'm just trying to digest and yeah. So it's really good. The video itself is there on our YouTube channel. So if the people have missed this one, they can go back and then watch the YouTube video as well. Thanks, Nandini and Nandini again, and see you again. Thank you.
Thank you
Bye.
so much. Thank you so much. Take care. Bye bye. Thank you, everyone.